Hello everybody and welcome back to another video. So for today's video, we're going to be going over another one of you guys' questions. Hopefully we can get you guys some good answers. But as always, before we start a video, I like to point out, and I even made it part of my description on my YouTube channel now, this little thing right here, just an FYI quick disclaimer that I am just a random dude on the internet posting videos to share what I know, but nothing I post is meant for use in a production environment. Please always make sure you're following best practices and understand what you're doing before you copy and paste code into your own environment. All my uploads are only for fun education purposes. So with that said, let's jump into your question. So in my most recent video, the Salesforce Apex REST Callouts post request perform Apex callout from trigger video, I received this question from ASMR Relaxing. They said, Chris, make some videos on how to write test class for this post get request. And yeah, I think we can get that done today. So let's jump into it. Now, as a very quick reminder for this previous video, or rather in case you haven't seen that video, what we did in that video was we came up with this little scenario to kind of justify doing a post callout request. And the scenario in which we made up was we received some requests from higher up that they needed us to send some supply data to an external service when the status is changed to active. And here are the different fields that they expect to be sent along to this external service. And as well, regarding that external service, I very quickly made up a small little project using some NPM libraries that basically spins up a little dummy server and allows us to call that endpoint and post some data to it. It's not perfect, but it works. If you guys are interested in seeing more about this, feel free to watch that video. I'll link it down somewhere for you guys to watch that. But anyways, the important part is we have an endpoint, or we had an endpoint that we can call to post some data to it, allowing us to basically talk about how to do a post callout request. Okay, so with that said, today we want to cover how to, write a task class for all this stuff. So very quickly again, here is our trigger. It is only firing on before update. It's calling this method right here, before update on this class. In this class, all it's doing is it's calling the send supply to JSON server method from the supply callouts method, or class, sorry. It's passing in an old map of that supply data and then a new list containing that supply data as well. In our supply callouts Apex class, we have all our logic. Again, I'm not going to go too in depth about what everything does in here because I already did a video covering that. This is more so a video just to cover the test class portion of it. But with that said, I do quickly want to go over some small tweaks I made here and there. Namely, one being that instead of using a list let me back up a little bit. This send supply to JSON server method is responsible for determining which supply records to send to our external service, and also calling the method to send it to actually post request. Previously, we were using a list to hold those supplies that we deemed to be active, but now I am using a map of IDs and supplies to do so instead. And the reason for doing that is because I wanted to be able to do a little extra in our callout. And basically now what we're doing, once we iterate through all our supply records and determine which one is active, and again, I don't want to get too deep into it, but the way we determined that was by looking at the old instance of that record and seeing that it is not equal to the new instance of that record, and that the new instance of that record has the status set to active. So if that criteria is met, we deem it to be ready to be sent to our external endpoint. And when we do that, we just add it to our map. We're adding the ID of that record to as the key, and then the value as the whole record itself. And then what we do here, kind of arbitrary, but I just picked a field at random to basically just kind of provide some information about what happens to that record, namely that we kind of queued it up for transfer to that JSON server. So pretty much the same there. The big difference here is in our perform post callout method, which I think I slightly renamed it. Not a big deal. Previously, we were just sending that supply payload data to that method. Now we're also sending those IDs as a key set. So you might recall when you use the key set method on a map, it gives you a list for the keys. So you can think of this, I have a list or array of IDs of our supplies. So anyways, in our perform post callout method, everything's the same, except now we have that set of IDs. Sorry, I think I said list, it actually returns a set. But anyways, so having this set of IDs, it allows us to do something once we have our response from the JSON server. And I think in the previous video I said I had like a little to do inside of our if statement here. Essentially, once we do our call out, we're going to get a response back from our external endpoint. And I said, maybe you would want to update those records that, that data that was sent. And maybe that external endpoint sends you some data back so that you can update your records in Salesforce. So I kind of took that idea and implemented it a little bit. So we're basically saying here that if we get a response code of 200 or 201, which basically indicates a success on my external endpoint, what I'm going to do is I'm going to query those those supplies that we had sent to the database. And the way we know that is by our supply ID set that we got up here when we stored them. So once we have those list of supplies, all I'm going to do is I'm going to just iterate through that animal, through those supplies again. And then in the animal payload field again, just kind of do a quick little update. Now we're adding some additional information. We're saying transfer to JSON server and then the timestamp. So no big deal, not much more work. At the end, we just do an update on the entire list and we're kind of good to go there. The one other difference that one other difference from the previous episode is you'll notice here, this is still a future callout, but I kind of abstracted the logic of the actual HTTP request to a different method. And I think this is the one we call post callout. So I know not really great naming convention, but it is what it is. So in this one right here, this method is the one responsible for doing the HTTP request and then returning the response. So, and you'll see quickly why I kind of did it this way, just because I kind of want to go over a few things in our test class. But one thing I do want to point out, you might be asking, why is the future annotation still on this method right here, as opposed to the actual method that's doing the request itself? Well, that's because this method is the one that's calling the post callout. So I could have a future right here, right, on this method right here, but this one's returning something. And as you might know with the future method, you're not allowed to return anything from a future method. So essentially the way I thought about this is the method that's handling the request and returning a response, it doesn't really care, whether it's future or not. The one that should be responsible for that is the one that's calling it, so to speak. And this is kind of a contrived example because I only did this because I want to show you guys stuff in the test class, but hopefully some of this makes sense. All right, so with that done, very quickly, I added an extra annotation called test visible, and that's just because I like to make my methods private unless I'm expecting to use them in a different class. And because it's private right here, I wouldn't be able to call this method in our test class. But because we have the test visible annotation, I can now go ahead and use that in our test class. So with that said, now we can go into our test class stuff. So to test callouts, what we need to do is we need to create an Apex class that implements the HttpCalloutMock interface. And what this allows us to do is basically create a fake response that our test code can use. And the reason why we're doing this is because test classes don't actually allow you to call an external endpoint. So we have to do this thing called the mocking. We're basically pretending that our test class is going to call the external endpoint, but we're not actually calling it. We're just going to make use of this thing right here. And this is sort of dumb. Like if you think about it, like why would you rely on an external endpoint to return data back to you? Like it's a potential failure point, right? And that's not really what we're testing with our test classes. What you should be testing is that the logic you're writing is correct, right? Like you shouldn't really worry that an endpoint is up and going. Because what if it's, what if it fails? What if it goes down for something or there's some maintenance to it? Then you wouldn't really be able to run your test cases at all. So in order to kind of get rid of that failure point, we create this mock class right here that will always return the exact same data back to you whenever you're calling it from the test class. So I hope that makes sense. And essentially in here, it's a very simple one, but we can kind of go over some things that might make it better if you're looking to do so. Like I said, we implement the HttpCalloutMock interface. That makes it so that we have to implement this respond method right here. The respond method has this HTTP request that's passed into it. And this right here, essentially when we do a call out in our test class, this method will fire and it will pass in the details of that request that we basically created for us. And then right in here, all I did was just create a very simple response that just return some very simple data. And I think that's it. So I'll kind of touch more upon this a bit later, but it's very simple. Just implement the HttpCalloutMock interface and then implement the respond method, create a response, and then just return it. The good stuff is in our test class itself. So in here, my test class is called supply callouts test. You'll see at the top, I have an is test annotation, and that's just to let Salesforce know that, this code should not count towards our Apex limits, and as well that it's a test class. So at the top, I have a private static string. I just call it supply JSON string that we'll use a little bit later. Our first method here has an annotation of test setup, and I just called it setup. And the way this works is for every single test method that we're going to define down below, this method will run before it. And essentially what this is doing is giving us some data to use for each method if we need it. This is going to be very useful if you're, for example, if you know that each one of your methods that you're going to create for your test cases are going to rely on some data. Well, instead of for example, creating the data in each method itself, well, you can just create it here knowing that this setup method is going to run once before every single method is going to be called in your test class. So hopefully that makes sense. In our case, all we're doing is we're just inserting one supply record into our testing. So, not too complex. So our first method here, and I should probably preface this by saying that testing can get very complex. And again, I'm by no means an expert, but I'll give him my best shot, right? Now, the way I kind of think about testing is, or at least in Salesforce, is you can test each component individually. So for example, if we go back to our supply callouts, we can, create a test case to say that to check that this whole thing works right here, or we can create a test case to make sure that our logic and our supply active method is working. We can essentially test bit by bit, but it really depends on how thorough you want to be. And I guess also how your org goes about doing things. I worked in a few environments here and there, and it really does depend on it, right? Some orgs only care about code coverage, which is not a good thing to do. So then some of them are very methodical in how they go about testing. So I'm only gonna cover the basics, right? But essentially, the way I see it, there's a few different ways of going about it. The first one is to really just make sure that our, for example, this method, which is doing the request, is actually working. Now, I don't really see too much point in creating a test case to make sure that our post callout method that has the HTTP request is actually working. But I guess if you needed to do so for some reason, or perhaps there's more logic in that method for you, what you can kind of do is something like this right here, right? So I have this method called test post callout returns response. And the way it works is we make use of test.startTest and test.stopTest. And we do this because since I had originally had the post callout logic right here that actually did the request inside of our future method right here, that made the code asynchronous, right? And basically meaning that you don't really know when that callout is going to be made. But now since it's in its own method, it kind of doesn't really matter much. But the idea with test.startTest and test.stopTest is that any asynchronous code that you write in here, it will be automatically executed or completed rather after the stop test. So you can ensure that, whether it's like a batch or like any other asynchronous process is done running, and that you're able to do some assertions on it, knowing 100% that asynchronous code ran. Well, that's the reason why you have these test.startTest and test.stopTest. So hopefully that makes sense. But inside of this start test and stop test, we're making use of this test.setMock method. And you'll see here, the first thing we pass into it is this thing called HttpCalloutMock.class. So we're passing it in the class definition. And then as a second argument, we're passing in an instance of our supply callouts, HttpCalloutMock. So basically this thing right here. And basically what this is doing is essentially saying, anytime that we do a call to a method that has a callout, instead of actually trying to do the callout, just grab whatever is in this supply callouts mock and then return whatever it is, right? So basically the way to think about this is here in the next line, we're doing a call to post callout, right? Which is this code right here. And in this code right here, we're doing an actual callout to an endpoint. But because we're doing this in our testing, it's going to reach into the supply callouts HttpCalloutMock and then just essentially return this stuff right here. So essentially this response is going to have that mocked up HTTP callout that we did. Hopefully that makes sense. I know I've said that like 10 times already, but I truly hope that makes sense. So now what we can do with this response is do some assertions with it. So like, for example, here I'm asserting that the response code is 200 and then the body is that supply JSON string we defined up here, which I basically just copied from right here. Now, like I said, I kind of don't really see too much point in doing this aside from code coverage, or perhaps like there's more logic in your post callout method that requires you to do like some, additional testing. What I kind of would prefer to do in this specific case, now, I like how I said before, I don't like to speak in absolutes. I'm sure there's always a reason for doing things differently, and then perhaps I'm doing this wrong. Maybe I just learned it. I just learned it this way, and that's kind of what's worked for me. But anyways, what I would much rather do is test a bit more of the code, right? And what I mean by that is this test method right here, which I've called test supply post callout on active. Now I'm kind of like testing a bit more of the system, right? And perhaps this could have been broken out into like, different components, or rather more methods that test specific portions of the code. But here, what I'm more interested in doing is kind of like running through the entire chain of events, right? Still, we have our test.start test. We have our test set mock to make sure that any callouts we do instead using that callout mock that we created. And in here, first thing we're doing is we're doing a query to get our test supply that we have defined in our test setup method. Once we have that, I'm just doing some simple assertions to it. I'm just checking that only one was created and that it's in a draft, and that there's nothing in the animal's payload, just simple things. And then what we're doing here is I am setting this to active, and I'm updating the test supply list. That should only contain that one record. And if you recall, this is essentially going to make that before update fire, which will then make this all our logic fire to queue it up to be sent to the JSON server because we did the update. And then once we're done with that, I'm going to call the stop test to make sure all our logic has fired. Once we have that, I then again query that record, and then I do some assertions, right? So I'm still making sure that there's only one record in there because we only have one record. I'm now making sure that the status is active. I'm then making sure that the animal's payload is now not blank because our logic, was adding information to that field. And then additionally, in the last two assertions, I am checking to make sure that it contains this string right here, queued for transfer to JSON, and that it also contains this information right here, transfer to JSON server, as well as the messages right here. And I guess I should probably explain this since I was too lazy to write this code out with you guys, just in case you guys are not too familiar with assertions. So you see here, as I'm writing this out, there's a couple of different asserts that you can do. There's assert, you just pass in one condition, or a condition with the message, or if there's assert equals, assert not equals, so on and so forth. I make use of assert equals or just assert, it doesn't really matter. I like to use the one that has the three different arguments, so expected, actual, and message as an example. And the message is shown to you in case that your assertion failed, right? So as an example, let's say that for some reason the status of this record was not active. Well, then when you run this test class and you get a failure, you'll see this message printed out to the screen that kind of gives you an indication about what went wrong. So yeah, hopefully that makes sense. So I guess now we can kind of go ahead and just run this test. So I'll just hit run all test, and it should take a few seconds probably. So we'll see here, yep, it looks like it ran just fine and all our tests passed. So again, I know this is a bit more of a rush video and it's a slightly different format than I usually do. I usually like to go ahead and like write the code with you guys, but I was feeling kind of lazy. And like how I said many times in the past, kind of try to stay away from doing test class videos because they can be kind of complex, and depending on the developer you speak to and the org you're at, you can be doing them right or wrong depending on the person, I guess. So, but yeah, hopefully this gives you some insight into how you would test. And like I said, you could just test to make sure that the HTTP request that you're doing is returning the exact same things you want, or you can test a bit more about it. This is kind of just how I've done it and how I've been taught. But, let me know if you guys do it differently, if I'm doing it completely wrong. I would really like to hear from you guys. But before I go, one more thing. In our supply callouts HttpCalloutMock class, I said that we could kind of go over a bit more about this. Now you'll see here that we're always just kind of returning the same thing, right? But what you could do is, if you needed to differentiate between doing a post or a get or a patch or a put or whatever, what you could do is something like this, right? So we can have an if condition right here, and we can do if the request is, let's get the method right here. So we can say something like, if the request that is being done when this thing gets called is a post, then then say something like, you know, like set the body to like post something, right? And else if the request.get method is get, well, then you can like, you know, do different different things for the response properties, right? I think you guys kind of get the point. So yeah, you can do something like this if you needed that kind of like, I guess, like detail or like exactness in your code. This would allow you to send different things for your response properties instead. So this is just a very simple example. So I didn't make use of that. We were only doing a post, not a get. But yeah, I hope this kind of makes sense. Again, if you guys have any questions, feel free to leave them down below in the comments. If you guys have any other questions about any other topics that you guys want to see me make a video about, also feel free to leave them down in the comment section below. If you guys found this useful, consider subscribing. I would greatly appreciate it. And I'll see you guys in the next video.